Understanding Agent Behaviors in Game Environments. This video introduces the PlayerViz component of the common Games Understanding and Learning Toolkit, which is used to understand both artificial and human player behaviors.
Computer games provide fertile ground for doing advanced agent work, both in the understanding of human-controlled characters and in the improvement of artificial characters for tasks such as training, skill evaluation, and entertainment. In order to better understand the behavior of the AI or human players, we must track what actions they perform in these environments. In this work, we focus on first- and third-person interactive games. The two main variables we need to track are the player's position and orientation in the environment, or simply where they are and where they are looking. If we track this information over time, it produces lots of data about their interaction with the game world. However, collecting these features from an interactive experience can result in a large amount of data that is often very hard to interpret from just the numbers. To make it easier to understand, we can represent it visually as a player trace using PlayerViz. The curve of connected spheres, or player trace, represents the player's position at a point, and the line segments extending from the spheres indicate the player's orientation in time. The passage of time is indicated by the coloring of the curve using a rainbow color scale, starting at the beginning in blue and ending at red. Bunching of colors indicates slower movement, and stretching of colors, faster movement. Other interactions may also be noted visually, such as the opening of a door indicated by a red sphere at the end of the orientation stick.
Once we have collected a large set of player traces, we can use the process of visual data mining to discover patterns that can provide knowledge about player behavior in the environment. First, we must organize the collected information in a visual manner. Using PlayerViz, we can generate useful information in a collection of web pages for a domain analyst to examine. The goal of the analyst is to find interesting elements or anomalies in player behavior that need to be investigated. Once found, these anomalies can be automatically detected in the entire dataset by creating a math model to locate the patterns.
When looking through the player traces, we discovered that some players were turning 360 degrees while standing still. We call this a pirouette, and it indicates that the player was lost or reorienting themselves. This can also indicate problems with an agent's navigation algorithm or in their percept stream.
We also discovered points in a player trace where the player's view direction gets stuck looking up or down for a period of time. This is usually due to a loss of control or gimbal lock in the rotation angles. We can help the players if this happens by forcing their viewpoint in the right direction.
We also found that some players would constantly jump through the environment. This is a tactic that is utilized by experienced human players to make themselves harder to hit. In cooperative gameplay, if detected, an agent could know when a player is a jumper and adapt their strategy to match or complement.
We can also use visual data mining techniques to detect learning between multiple play sessions by the same player, thus quantifying learning gains. Here we see a player that was trapped by rows of crates. They did not learn initially that they could break the crates and escape. We can see the positive learning by comparing their first player trace with their second, in which they break the crate and escape right away.
Another useful application is discovering unexpected or emergent player behavior. In this example, the first trace shows what a player should have done to reach the goal. The second trace is what this player did, which was to climb the side of the building, walk on the roof, and then drop down onto the goal. This type of emergent behavior would be hard to identify without visual representation.
In conclusion, visual representation of player behavior in a game environment can help provide useful knowledge about the player's interactions within the game world. This knowledge can be used to better understand agent behavior and to improve agent interaction.